Good morning. Today we'll see about feedback topologies. General structure of the feedback amplifier. The feedback amplifier will have source, amplifier, feedback network, load, mixer and a summing point. Mixer or summing point. From the source, the signal X S is given to the mixer network, and from the output the output is fed back to the input, and the output of the feedback signal is denoted as XF, which are combined together in the mixer network, and the output is produced, which is denoted as Xi, that is given to the input of the input to the amplifier. Then the amplifier output is denoted by X naught, that is given to the load. If X naught is equal to A into Xi, that is output of the amplifier is given by A into Xi, and output of the feedback network is given by beta into X naught. If then the mixer output of the mixer stage is Xi is equal to Xs minus Xf. The gain of the amplifier A is equal to output by input, that is X naught by Xi, which is equal to A by 1 plus A beta, where beta is the feedback factor and A beta is the loop gain, and 1 plus A beta is amount of feedback. If A beta is very much greater than 1, then AF is approximately equal to 1 by beta. The gain of the feedback amplifier is almost determined by the feedback network. The feedback signal Xf is equal to A beta by 1 plus A beta into Xs. For A beta is very much greater than 1, we can see that Xf is approximately equal to Xs. Then the output of the mixer stage, that is Xi is equal to 0, therefore that is which is called as error signal. Four basic feedback topologies are based on the quantity of the to be amplified, that is voltage or current, and on the desired form of the output voltage or current. Amplifiers are classified into four stages: voltage amplifier, current amplifier, transconductance amplifier and transresistance amplifier. Four basic feedback topologies are voltage sampling, series mixing, that is series shunt topology; current sampling, shunt mixing, shunt series topology; current sampling, series mixing, series topology; voltage sampling, shunt mixing, shunt topology. Voltage amplifiers. Voltage amplifiers has some basic characteristics. Input signal is voltage and output signal is also voltage, and it is a voltage controlled voltage source. Then it has high input impedance and low output impedance. Voltage amplifier has voltage sampling, series mixing, that is series shunt topology. The feedback network samples the output voltage, and the feedback signal Xf is the voltage that can be mixed with the source voltage in series. Series refers to the connection at the input, and shunt refers to the connection at the output. This is called as series shunt topology. First, series represents the connection at the input, and the second term represents the connection at the output. The characteristics of this topology are: stabilizes the voltage gain, high input resistance and low output resistance. The circuit for series shunt topology is given here. Series shunt means series represents connection at the input, that is from the input voltage Vs and amplifier input, both are in series to the feedback network, and the second term shunt represents the connection at the output, where in the output the terminals are connected in parallel. Next is current amplifiers. It also has some characteristics. What are they? Means input signals are current and output signals are also current. This is so it is called as current controlled current source. In this type, impedances have low input impedances and high output impedances. Feedback topology is current sampling shunt mixing, that is shunt series topology. Shunt series means shunt represents connection at the input and series represents the connection at the output. The feedback network samples the output current and the feedback signal is the current that can be mixed in shunt with the source current. Shunt refers to the connection at the input and series refers to the connection at the output. This type of current amplifiers stabilizes the current gain, lower the input resistance, higher output resistance. The circuit for shunt series topology is given, where shunt means we should refer the input connection. So here at the input side it has parallel connections, and the output side the sampling network has series connection. So this type of connection is called as shunt series topology. Third one is transconductance amplifier. Here the input signal is voltage and output signal is current. So this is called as voltage controlled current source, which has high input impedance and high output impedance. The frequency feedback topology is current sampling series mixing, that is series topology. Both input and output has series connections. The feedback network samples the output current and the feedback signal is the voltage that can be mixed with the source voltage in series. Here series refers to the connection at the input and the second term series refers to the connection at the output. Transconductance amplifier has some characteristics, that is it stabilizes the transconductance gain and higher input resistance and higher output resistance are achieved. This is a block of series topology, where at the input of the amplifier and the output of the amplifier we have series connections, that is the mixer stage also series and the sampling stage is also connected in series. Last one is transresistance amplifier. Here the input signal is current and the output signal is voltage. Hence it is called as current controlled voltage source. Current controlled voltage source which has low input impedance and low output impedance. The feedback topology is voltage sampling shunt mixing, that is shunt topology. Both input and output has parallel connections. The feedback network samples the output voltage and the feedback signal XF is a current which can be mixed in shunt with this current source. Shunt, both the shunt refers to the connection at the input and connection at the output, which that is both input and output side have the shunt connection. The characteristics of this amplifier is it stabilizes the transresistance gain and which has lower input resistance and lower output resistance. So the block diagram for the shunt topology is given, where The amplifier input and the amplifier output both are connected in parallel, both have parallel connections. Both the terminals will have the parallel connections. Then coming to the two-port network parameters. Each amplifier have some network parameters. So here we have 4 parameters: Y parameter, Z parameter, H parameter and G parameters. In Y parameter, here the two-port network is connected with the input voltage and the output voltage, that is V1 and V2. Two voltages are connected in the input side and the output side, which is denoted as V1 and V2, and the current direction is shown, which is it has two currents, I1 and I2. The parameters are denoted by Y11, Y12, Y21 and Y22. These are the Y parameters. This first block is elaborated in the next session, where these blocks have the parameters Y11, Y12, Y21 and Y22. Here Y11 can be written as I1 by V1 and Y12 can be written as I1 by V2. Y21 is equal to I2 by V1 and Y22 is equal to I2 by V2. So in general, from this two-port network we can find the current I1 and I2. I1 can be written as Y11 into V1 plus Y12 into V2. The second current I2 is equal to Y21 into V1 plus Y22 into V2. Next, Z parameter. Here in Z parameter, the two-port network has two current sources, I1 and I2. So here I1 and I2 are the source currents. So from this we can find V1 and V2. V1 equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Likewise, H parameters. H parameter has input current source and voltage source, that is from the input side. In the input side of the two-port network, current source is given and the output side of the two-port network, voltage source is given. So from this we can find V1 and I2. Similarly, for the G parameter, two-port network has input voltage source and the output current source. So from this we can calculate I1 and V2. Thank you.